Today we are going to solve the question 19. In question 19 it is asked to compute the uncertainty relation where it is given the delta x square means the dispersion of sx square its expectation is equal to, as we know, sx square its expectation minus expectation of sx square, and here this expectation is taken for the sz plus state. Using your result, check the generalized uncertainty relation. We have to check this. Here a is sx and b is sy, and in the question b it is asked check the uncertainty relation with a sx comma b sy for sx plus state. Now let us check the question a first. To solve the question a, let us memorize one of the result that we have one of the result of the problem that we have solved early, which is question 8 and question 9. From question 8 we know that commutation of sx comma sy is equal to I h cut sz, and from question 9 we know that if an operator s cap n cap, if for an operator the eigenstate of this operator is suppose alpha, then this alpha can be represented in terms of the eigengates of the plus sz basis and minus sz basis. How we can do so? First recap this. Here n cap is a unit vector which this is z axis, this is x axis, and this is y axis. This n cap has a projection on xy plane. This projection makes an angle alpha with the x axis, and n cap makes an angle beta with the z axis. Then this alpha can be written as cos beta by 2 plus this plus is corresponding to the eigenstate of the sz plus sine beta by 2 e to the power I alpha minus. So we are going to use this result from question 9 and this result in question 8. So let us solve the problem A. So to calculate the uncertainty, we have to first calculate the expectation of sx in this state plus sz. Now the sx means s dot x cap. This x cap then this x cap makes an angle. This is not x cap, sorry. This is x cap. So this is x cap. X cap makes an angle beta, where beta is pi by 2 here. This angle is pi by 2, and it doesn't make any angle with x axis. That means the angle is alpha is 0. That means for s cap, beta is equal to pi by 2 and alpha is equal to 0. That means we can write this the eigen vector or eigengates of the sx operator as plus Sx will be e to the power cos beta by 2 means pi by 4 plus Sz plus I to the power I alpha means 0 sin beta by 2 minus Sz. And sin beta by 2, what is the value of sin beta by? Sin beta by 2 means sin pi by 4 and we know that the value of cos pi by 4 and sin pi by 4 is 1 by root 2. That means 1 by root 2 plus Sz plus of minus Sz. Similarly, we can calculate plus minus Sx minus Sx for minus x cap. The beta will be pi by 2, but the alpha will be then pi. So then alpha will be pi. So then minus Sx will be cos pi by 4 plus Sz plus sin pi by 4 e to the power I pi minus Sz. That means 1 by root 2 plus Sz plus minus e to the power I pi means it is minus the value of e to the power I pi is minus 1, so minus Sz. So that means from these two, so from this and this we can write the plus Sz as a combination of 1 by root 2. If we solve these two equations, if we add the two equations, then we will get plus Sz is equal to 1 by root 2 plus Sx plus of minus Sx. So we can also write this Sz in terms of Sx, and again minus. Similarly, if we subtract this from this equation, we will get minus Sz is equal to 1 by root 2 plus Sx minus Sx. So now we have expressed plus Sz in terms of Sx. Actually, we have to express in this form because we want to calculate the expectation value of Sx. If we express Sz in terms of Sx, the calculation of expectation value of Sx will be easier. Now let us check the expectation. How can we write the Sy eigengates in terms of Sz? So let us check that. So for Sy, that means y cap makes an angles with z pi by 2 and y also makes an angle alpha is equal to also here pi by 2. So here beta is, so for y cap alpha is equal to pi by 2 and beta also is equal to pi by 2. So from here we write that plus Sy is equal to cos pi by 4 plus sz plus e to the power I pi by 2 sin pi by 4 minus sz, which is cos pi by 4 means 1 by root 2, that is 1 by root 2 plus sz, and e to the power I pi by 2 means e to the power I pi by 2 means cos pi by 2 plus I sin pi by 2, which is nothing but cos pi by 2 means 0 I, so it is equal to plus I minus sz. Similarly, the angle between the x and minus y axis, what it will be? It will be minus pi by 2. What it will be? Minus pi by 2. Then from the similar expression we can write minus sy is equal to 1 by root 2 plus sz minus I minus sz, and again this sz again can be written in terms of sy and in terms of plus sy and minus sy. How? This will be plus sy, sorry, plus sz, here it is sz is equal to, if we add these two terms, we will get 1 by root 2 plus is y plus of minus now if we subtract these two equations, we will get let us subtract these two equations. If we subtract this equation from this equation, we will get plus sy minus sy plus sy minus sy is equal to 2I by root 2 minus sz. So that means this sz minus sz can be written as minus I by root 2 plus sy minus sy. So this will be 2. So this, from this and this relation, we can say that we can express sy plus sy and minus sy in terms of plus sy and so from this equation and this equation, again we can see that we can also written plus sz and minus sz in terms of sy plus sy and minus sy. Now let us calculate the expectation value of the sx in state plus sz. What it is? We know s plus sz, sx plus sz. Now this plus sz can be written as 1 by root 2 plus sx plus of minus sx. If we operate sx on this state, what we will get? Let's see. 1 by root 2, this will give sx plus h cut by 2 sx, this will give minus h cut by 2 minus sx. That means it will give h cut by 2 is z minus sz, and that means h cut by 2 plus sz minus sz. From the orthonormality relation, we know that this is equal to 0. So the expectation value of sx in this base is equal to 0. Now let us calculate the sx square. So if we operate sx again in this state, we will get 1 by root 2 h cut by 2 plus sx minus sx. So that will give 1 by root 2 h cut by 2. It will operate in this state, give us h cut by 2 plus sx. This will give minus and minus plus h cut by 2. There is a 1 minus, and when sx operate in minus sx, it will give another minus. This will become h cut by 2 plus minus sx. So that means h cut square by 4 plus sz. That means we will get the expectation value of sx square in this state plus sz is h cut square by 4. So the dispersion delta s square will be h cut square by 4. Now let us calculate the dispersion of the sy. So plus sz sy plus sz, and we previously saw that the plus sz can be written in terms of the eigenkets of sy. So let us express in this term. So sy operate on sz means sy operate on plus sy, which is a eigenkets of sy, plus minus sy, which again an eigenkets of sy. So it will give 1 by root 2 h cut by 2. This will give plus sy, and when we operate in this state, it will give minus h cut by 2, which means minus sy. That means it is h cut by 2 minus sz minus, it is not minus sz, it is actually, this is minus sz. That means there will be a minus I factor here into 1 by minus I. So what it means, let us see that. Plus sy minus sy is 1 by root 2 will be minus sz by minus I, minus sz by minus I, which means I h cut by 2 minus sz. So if we write it here, that means I h cut by 2 plus sz minus sz, which is actually 0. Now let us calculate sy square, expectation value of sx square. So if we operate sy here, or we can do another thing, that since we know we know that Sy operate on plus sz will give I h cut by 2 minus sz. So we can do one thing, that we operate Sy in this state, we know that, and Sy, since Sy is Hermitian, so we can calculate easily. So it will be nothing but the dual correspondence of Sy plus Sz. So let us calculate it. Sz. So it will, the dual correspondence of this will be imaginary part of this and bra of this. So that will be minus Sz, and imaginary part means minus I h cut by 2, and this will give minus Sz and I h cut by 2. So we will get h cut square by 4. So the dispersion relation of Sy square, its expectation value on the state Sz plus Sz will give h cut square by 4. Now let us calculate the expectation value of the Sx comma Sy, and from the result of question 8 we know that, from the question result of the question 8 we know that Sx comma Sy is equal to I h cut Sz. That means it is equal to I h cut expectation value of Sz, and we know that the expectation value of Sz on the plus Sz will be nothing but h cut by 2. So here I h cut into h cut by 2. So what is its mod its square? This means mod of the square. Mod of the square will be h cut square by 4. So that means delta Sx square, its expectation, into delta Sy, its square, its expectation, is equal to h cut square by 4 into h cut square by 4, that is equal to h cut square by 16. So from the uncertainty relation we know that this should be delta Sx square, delta Sy square should greater than or equal to expectation of commutation of Sx and Sy, its square. So here this is h cut square by 16, and this value is also 1 by 4 into this. So this value is h cut square by 4 into 1 by 4, that is h cut square by 16, which means here the delta Sx square, its expectation, and delta Sy, its expectation, is equal to 1 by 4. So that means it holds the equality of the uncertainty relation. So it holds the uncertainty relation. So it is asked in the question 18 to 19 to check the whether or not these Sx and Sy operator holds the uncertainty relation. So we have done the first part of the question 1. Now let us focus on the second part of the question 19, that is B. Here it is asked what it is asked here. It is asked, that is, let us change the color of the pen. So here it asks to check the uncertainty relation with A Sx B Sy for Sx plus state. Now the state is Sx plus. So we know that, first let us calculate in B what will be the dispersion of Sx square in its eigenstate. Since there will be no uncertainty of measuring the value corresponding to the observable Sx in its eigengates, that means Sx square equal to 0. Let us calculate that. Delta Sx means Sx minus expectation value Sx. Now if we want to calculate its square its expectation, that means square expectation its square. So now if this expectation is over the eigengates of Sx, what it will be? Sx operate on plus Sx plus Sx, it will give h cut by 2 and plus Sx square, it will give h cut square by 4. So that means h cut square by 4 minus h cut by 2 its square, that means will give 0. So this will 0. That means the left hand side of the uncertainty relation will give 0, that delta Sx square is expectation, delta Sy square its expectation will give 0. Now let us calculate the right hand side of the uncertainty relation, that means 1 by 4 expectation value of Sx Sy its square. So let us calculate that. As we know that the value of Sx Sy is equal to I h cut Sz. So if we operate Sz on plus, so we have to calculate the expectation value of Sz in plus Sx state, and we know that we can express the plus Sx eigengates in terms of Sz eigengates as follows: 1 by root 2 plus Sz plus minus Sz. So if we operate Sz on this state, we will get 1 by root 2 plus Sz minus, there will be a h cut by 2. Operating Sz on the eigengate plus Sz, it will give h cut by 2, and operate on this state, Sz will give minus h cut by 2 minus Sz. So that means that is h cut by 2 into minus Sx. So from here we will get h cut by 2 plus Sx minus Sx, that means it is 0. And what is square? The square of the 0 will be again 0. So that means again the delta Sx square its expectation and delta Sy its square its expectation is equal to 1 by 4, since Sx Sy its expectation its square will be 0. So that means this equal to 0. So that means again the uncertainty relation hold even in this state of when the expectation value over the state plus Sx. So hence we have solved the question 19. Now let us solve the question 20. So now we will solve the question 20. Here it is asked, find the linear combination of plus and minus gates. Here the plus and minus gates is the eigengates of the Sz operator, gates that maximizes the uncertainty product delta Sx square and delta Sy square. So let us assume any arbitrary gate n equal to alpha plus root over of 1 minus alpha square e to the power I beta minus. We have choose this alpha and 1 minus root over alpha square because to normalize the state, if we operate nn, it will give alpha square plus root over of 1 minus alpha square, it will give 1. And here we assume that alpha is a real number. It is not an imaginary number, it is a real number, real positive number, real positive number. That means, and it is less than, here we have explicitly assumed that alpha is a real number and its value will be less than equal to 1. Real positive number and its value is less than, this alpha remains between 0 to 1. Here we assume that. Now let us operate. Now let us calculate the delta Sx square in this state. So Sx operate on this n state will, what will you get? As we know that Sx operating on plus half, it will give minus half h cut by 2 h minus, and then plus by alpha square e to the power I beta. Sx operate on minus, it will give plus and h cut by 2. So that means we'll get h cut by 2 alpha minus plus root over of 1 minus alpha square e to the power I beta plus. So let us calculate the expectation value of Sx. That means Sx, what it will be? It will be h cut by 2 alpha plus e to the power minus beta root over of 1 minus alpha square minus, and then Sx n cap means h cut by 2 alpha minus plus root over 1 minus alpha square e to the power I beta plus. So that will give h cut by 2 alpha root 1 minus alpha square e to the power I beta, and this operate on this will give 1, and this operator on this will give 1, and another term will give 0, plus minus will 0, minus plus will be 0. So this root over alpha square plus beta plus alpha root over of 1 minus alpha square e to the power minus I beta. So that is h cut by 2 into alpha by root 1 minus alpha square by 2 e to the power I beta plus e to the power minus I beta by 2. So here we take these two here, so there will be no 2. So this is h cut by h cut alpha root over 1 minus alpha square. This will be cos beta. Now let us calculate the, what is the value of n Sx square n. That will be, if we operate these, so that will be, that means n Sx and Sx n. So this means h cut by 2, this will be alpha plus, sorry, alpha, what it will be? It will be alpha minus plus root over of 1 minus alpha square e to the power minus I beta plus, and again this step, alpha minus plus root over of 1 minus alpha square. There will be h cut square by 4 square e to the power I beta plus. So this will give h cut square by 4 alpha, operate on this alpha, give alpha square 1 root over 1 minus alpha square, given alpha square will give 1 minus alpha square, that will give h cut square by 4. So now the dispersion will be delta s square, its dispersion will be h cut square by 4 minus h cut alpha h cut square alpha square 1 minus alpha square cos a square beta. Now what will be the, let us calculate this for sy. So at first we have to calculate sy, its expectation, which will be, let us operate sy on the state n, that means sy on the state alpha plus root over of 1 minus alpha square e to the power I beta into minus. We know that sy operate on plus, what it will give, let us check in the previous question. From the previous question we know that if sy operate on plus sz will give I h cut by 2 minus sz. So that means it will give alpha sy plus will keep I h cut by 2 minus, and here it will give minus I h cut by 2 root over of 1 minus alpha square e to the power I beta minus 2 plus. Now let us, here is alpha, that means it will give this, that means I h cut by 2 alpha minus h cut by, sorry, h cut by, have common h cut by 2, so minus root over 1 minus alpha square e to the power I beta plus. That means expectation value of sy will be alpha n plus root over of 1 minus alpha square e to the power minus I beta, this is plus, this will be minus this, and I h cut by 2 alpha minus 1 minus alpha square e to the power I beta plus. So let us calculate what is value. So its value will be, this operator on this will give 1, that means minus alpha root over of 1 minus alpha square e to the power I beta plus will give, so this means so I beta, this will be I beta, and this operator on this will give 0, this operator on this will give 1, that means minus alpha root over of 1 minus alpha square e to the power minus I beta, and there is I h cut by. So this means h cut by 2I, this is plus, this will be plus. So that means alpha root over of 1 minus alpha square into e to the power I beta minus e to the power minus I beta, which will be h cut by 2, h cut by, there will no 2, so that means h cut alpha root over 1 minus alpha square, this by 2I will be sine beta. And what will be the value of sy square expectation? Similar, since similar to this will be this and this will be n sy n, which again will give this and this, that means minus h cut by 2 alpha minus plus root over of 1 minus alpha square e to the power minus I beta minus, this is plus, this is minus, plus alpha plus root over of 1 minus alpha square e to the power plus I beta minus. So this will give nothing but, there will be plus h cut by 2 h cut square by 4. That means the dispersion will be h cut square by 4 minus h cut square alpha root over 1 minus alpha square sine square beta. So let us calculate the delta sx square multiply delta sy square. What it is value? Value at h cut square by 4 minus h cut square by h cut square alpha root over 1 minus alpha square sine square beta, and this is cos square beta and this is sine square beta. H cut square by 4 minus h cut square alpha root over 1 minus alpha square sine square beta, that is h cut square by 16 minus h cut square by 4 h cut square by 4 alpha root over 1 minus alpha square its square, no, there will be no square, it is, let us, it will be h cut square by 4 its square and plus h cut square alpha root over of 1 minus alpha square its square by 4 to sine beta cos beta its square, and there will be another minus h cut square by 4 into h cut square alpha root over 1 minus alpha square cos square beta plus sine square beta. That means it will give h cut square by 16 plus h to the power 4 by 16 h to the power 4 by 4 alpha square into 1 minus alpha square into sine, this will be sine 2 beta and this will be minus h cut to the power 4 by 4 alpha root 1 minus alpha square, since cos square beta plus sine square beta is equal to 1. that means h, if we common h to the power 4 by 4, it will give square by 4, it will give, if we common h square by 16, that means we will get 1 minus 4 h to the power 4 alpha root over 1 minus alpha square plus 4 h to the power 4 alpha square 1 minus alpha square sine square 2 beta, sine square 2 beta. Now if we want to maximize this multiplication, we have to maximize these terms first. So this term will be maximized when sine 2 beta will be maximum. Sine, the value of maximum value of sine 2 beta is 1, and from here we can calculate beta is equal to 2 beta is equal to pi by 2, sine pi by 2 is equal to 1, that means beta equal to pi by 4. Now if we put this value here, then it will become h to the power 4 by 16 1 minus 4 h to the power 4 alpha root over 1 minus alpha square plus 4 h to the power 4. There will be no h to the power 4 since we common it, so yeah, there is no h to the power 4, there also no h to the power 4, so there will be no h to the power 4, no h to the power 4. So 4 alpha square to 1 minus alpha square, so that is nothing but h to the power 4 by 16 1 minus 2 alpha root over 1 minus alpha square, its square. Now so I think here we do one wrong thing, that is this is not this will be actually alpha square 1 alpha square, again hy square, since expectation value is h cut alpha 1 minus alpha square, its square will be, so there also alpha square, and x square there also we have sx square we write correctly, but sx square we have write it wrongly, so there here will be an square there is also square so every root and it's replaced by square, so here also it is square, these will be to the power square, again these will be square and square, there will be a whole square, and there is square, and this will be square. So here in the final value we'll get this is square, this is whole square. So here what we'll get its square into 1 minus alpha square. So now for what value this value will be maximum, what value of alpha, let us calculate that. First calculate this will be extreme when inside value will be extreme, and we know that for extreme value of this function then will be del alpha 1 minus 2 alpha square, 1 minus alpha square should equal to 0, that means 2 alpha 1 minus alpha square minus alpha to 2 alpha square into 2 alpha is equal to 0. That means alpha into 1 minus 2 alpha square is equal to 0. So this function will be extreme for one value alpha equal to 0, another value alpha square is equal to half. So let us check what for alpha equal to 0 what we will get, and alpha square equal to half what we will get. For alpha equal to 0, from here we can see that it will give h cut square by 16, and for alpha square equal to half it will give 1 minus 2 into half its square, that will give 1 by 4, which is, that means which is less than from 1. That means for alpha equal to 0 we'll get the maximum value, which is maximum value of this multiplication, and its value is actually h cut to the power 4 by 16. This will be the maximum. Now what will be our state? N equal to alpha is 0 and beta is pi by 4. That means alpha is 0 means there will be alpha is 0 e to the power, that means root over 1 minus alpha square e to the power I beta will remain. That means alpha is 1 e to the power I pi by 4 minus. So this state actually give the maximum uncertainty of this function, of this dispersion delta x square, its expectation, multiply by delta sx square, its s square, its maximum. So here our arc state where the gate maximizes the uncertainty will be, the state will be e to the power I pi by 4 minus. Now in the last section it is asked the it is asked verify explicitly that for the linear combination you found the uncertainty relation is not violated. So here this is maximum. Let us calculate the what is the expectation value of sx comma sy, its average in this state. In this state it will be I, that means I squared by 2 sz, and it is minus I squared by 2 e to the power I pi by 4 minus I pi by 4 minus sz, minus here it will give I pi by 4. So that means it will give I h cut into h cut by 2 minus here will be minus sign, so I h cut square by 2. So its mod square will be its mod square. What it is? It is h cut square by 4. Now in the uncertainty relation we know that delta sx square delta sy square, its expectation should greater than equal to h cut square 1 by 4 square modulus of expectation of sx comma sy square. So here we will get this factor is h cut square by 16, and this factor is also h cut by 4 1 by 4 into h cut square by 4, that is equal to h cut square by 16. That means here also the uncertainty relation is not violated. Actually in this state the uncertainty relation hold equality sign. That means here delta sx square its expectation into delta sy square its expectation is equal to sx comma sy its square, which is equal to h cap square by 16. So we have solved the question 20. So thank you.